Alright, this is from the Honors Purple Book, Chapter 1, Lesson 6. It's on scientific notation. So we need to understand what scientific notation is. Scientific notation is a way that we can write really large or really small numbers in a way that's easily understandable. I always figured the reason they call it scientific notation is because where do you encounter those gigantic large numbers or those really small tiny numbers? There's a lot of times in science. Big numbers, like maybe other places you might deal with really large numbers, or like the national debt. Really small numbers would be like my bank account. But if we look at what scientific notation is in this form: a times 10 to the nth, where a is greater than or equal to 1 and less than 10. And n is an integer. So this n is an integer, so it can be positive, it can be negative, but it has to be a whole number, it's opposite. And a, this is really basically saying it's a one-digit number. You're going to have one number in the ones digit, and then you might have a decimal after. So I always think about it in this form. You're filling in these two blanks to put it into scientific notation. A power, right, which tells me how many places to move the decimal. If I'm taking times 10 to a power, 10 to the 0 power would be times 10 to the 0 is 1, right? So that's just times 1, it won't change it. But if I put a 1 there, I'll be moving the decimal one place to the right. If I put a 2 there, I'll be moving it 2 places to the right. If I put a 3 there, it'd be 10, would be 3 places to the right. If I put a -1, I'd be moving it 1 place to the left. So this is basically saying how many places do I need to move my decimal. Be careful, not how many zeros, how many places to move the decimal. And this number needs to be between 1 and 9.99999, or 9 repeating. In other words, it can't be 10. It's going to be at 1 or greater, right? And can't be 10, so it has to be less than that. So that's kind of what we're looking for. Alright, so let's do a couple of those problems. This is the guided practice off page 54. They want me to write this number in scientific notation. First of all, do you see it? It's a one number in the ones digit, right? It's less than 10, greater than 1, times 10 to an exponent. So that's telling me I need to move the decimal 5 times. It's really saying let me take it times 10 5 times. So watch. Times 10 times 10 times 10. There's 3, 4, and 5. So I'm going to fill those in with zeros. That would be 9931000. I've moved it 1, 2, 3, 4, 5 times. 993,100. This one I'm not moving it forward because this is times 10 to the -4th. We've talked about what a negative power looks like. Another way I could write 10 to the -4th is 1 over 10 to the 4th. So if I took this times 1 over 10 to the 4th, that would just be this over 10 to the 4th, or divided by 10 4 times. If you divide by 10, it moves the decimal to the left. So if I had this 6.02 over here and I moved it to the left, divide by 10, divide by 10, divide by 10, divided by 10, fill them in with zeros, I've moved it over 4 places. 0.000602. Tenths, hundredths, thousandths, 10,000s, 100,000s, millionths. This is 602 millionths. Alright, so the next one, they want me to write it in scientific notation. There's only one place I can put my decimal. Here's where my decimal is now. Only one place I can put my decimal to make that in between 1 and 9.999 repeating. Too big, too big, too big, too big, too big, too small, just right. So if you think about it, that makes it just right. I'm going to write it as 8.785. I include everything to where it maybe starts becoming all zeros, times 10 to a power. Remember, that power is telling me how many places I move the decimal. So I need to move it back 1, 2, 3, 4, 5, 6, 7, 8, 9 places. That'd be 10 to the 9th power. Because to move it from where I had it back to where it actually goes, I need to move it to the right 9 places. If I look at putting this one in scientific notation, it's less than 1. So when I move it to 5.24, once again, too big, too small, just right, 5.24 times 10 to a power. I need to move it back 1 place. That's the same as dividing by 10, so that'd be times 10 to the -1st power. Last thing I want you to be able to do is to compare these things. First of all, when you compare them, we're used to looking from the left on a decimal, so it looks like 7 is the biggest comparatively, but this is telling me that the decimal actually is in a different place. This decimal is not really between the 1 and the 2. It's not really between the 1 and the 1. It's 10 places over. It's 10 places over. It's only 6 places over. So really, this is saying this is giving me a better idea of place value than where the decimal is now. So if I'm looking at it, I'm going to reread that out of the book. Actually, I don't have my book with me, but I think it's least to greatest. If it's not, make sure you adjust. But always read to find out if it's least to greatest or greatest to least. But I would look at this and I would say that one's going to be the least. Rather than looking at the numbers out here, this is telling me the place value. We're at the smallest place value, so that's going to be my smallest one. So let me number these 1, 2, 3, and 4. Least to greatest, 3 is the smallest. Then I have this one, which would be the next one. So I would have 4 would be the second smallest. Now I'm looking at something that's the same power. So now I would go back over here, 1's match. So now I'm looking for the next smallest, 1.12 times 10 to the 10th. So there we are in order from least to greatest.